Hello and welcome. I'm Bill Wake. We're working on the decked card viewer. It lets us compare real and virtual cards and kind of integrate them a little bit. This time we're focused on the card list view. Today, or at the start of the session, I should say, because I'm making up a new start because we had some video glitches. At the start, we had just last week gotten the cards to show up as individual cards. They've got unique IDs, 63 versus 82F, but they were all showing the same picture. They were just showing a cropped portion of the main picture. And the crop is the right size, but it's in the wrong part of the image. Okay, so let's catch up to what we did in the first half hour or so of today's session. Let's close this. All right. This is GitHub for the decked stuff. So the big focus is that the old one we had the bounds, we took the min x and the min y, but really they have to be scaled by the image position. So the reason we're in the upper left corner is the values for min x and min y are in the range 0 to 1. But we need to scale them up to the image range. Okay, so they were actually all within kind of 0 to 1 pixels off from each other, not very visible. All right, but over here we multiplied the image size with times the bounds, image size height times the bounds, and that got us in the right place. So to make that, to improve that, I also changed CG Rect. Let's see. We have originally we had some hashable stuff. Now we moved in this bounds code, the scaling code in here. So the self min x, I guess the self is implicit, but we got min x times the size width times the size height and so on. And we added some tests for that. So that was kind of the first change in there that we did today. And what that did is it gave us access to the individual cards. All right, so let me move this another step forward. I don't know if I got a place to do that here. I guess I'll go like that. Okay, so here we pulled out the scale to and gave that over into the CG Rect helper. We had an extension class there, and now you just say bounds.scale to image size. Much more succinct than doing all these calculations again. Okay, and so once you've done that, let's see, can we run this? I don't think we've broken anything else. Okay, so we already had it doing the rectangles, but when you do them, you get the cards. Now these cards are all unique. Okay, they're positioned, extracted from the right position in the giant one. All right, but we have yacht, user starts turn, category choice of any, category 1s through 6s, and so on. All the cards that we identified out of that first screen. The thing I noticed that seemed funny is I'm looking at this card, big straight. And to me here, where I did the work directly, it looks like I got the card with a little tiny bit of border and no real issue on it. If I go back to the main image, big straight is this one in the middle on the bottom row. And it looks like my rectangle coordinates there are a little bit offset. Only on that one card. I don't know if some of that, maybe the width of the line is, it's drawing inside instead of outside or something like that, but it's a little funny. And maybe I should just note that as like an anomaly in here somewhere. So research somewhere, it's check red rectangles to make sure they're placed right. Okay, I'm not gonna do that. Yes, evil stuff. It's just odd. I don't know what else to say. It's like I've used this isn't the machine I'm using day to day now, but it's the machine I was using 3 months ago, and it always just worked, and today it just doesn't just work. So there you are. All right. Anyway, we've got scale by as an extension. I think we've successfully switched over to using that. It's working. We got rid of our spike. So now I'm trying to look with a little more critical eye on what we're doing here and think about what's next. Okay, so one thing I'm not quite liking, this well, it's hard to know where I want to draw lines, but the the cropping to me feels like part of the job of extracting cards. And so I think to some extent it doesn't really belong in this view class. So I would like to get that out. It's not clear to me if it belongs on the card class. I mean, everything about it is UI image stuff, and maybe I don't know if it's another utility kind of extension, but cropping this image to the bounds, it sure feels like the cards. Okay, so here we've got the cards. We've taken the image that we cropped up here, and we're loading that in the constructor. Oh, wait a minute, we don't have a constructor. Do we have cards yet? Maybe I'm way ahead of myself. Okay, we have cards that take an image. Are we using them in our content view? All right, card list says create a list, run through the cards. What's the type of card? Up here. Card, oh, it is a card. Okay, so somewhere I have a card constructor I'm calling. Where's that? Oh, right here. Okay. Yeah, in a sense, it's hard for me to know. What I'm doing is I'm cropping the image before I give it to the card because well, I don't know if Astrid's joined us today, but she gave good advice, right? It's like why should the card know about the whole image? There's no reason. So it seemed like it should know the partial image, and I just don't know if I'm not sure I want to test this really. I'm not sure. I think what I'll do is make an extension for UI image, which I thought existed, but we looked around and didn't see it. If anybody's a Mac or iOS programmer, speak up and let me know where it is. But um, it does feel like everything going on here is image related. So you pass in an image, it's very self-contained. Pass an image, pass in the bounds, give me back the cropped image. That does feel like what the card wants to know. Now, these identified rectangles, that's trickier. Okay, so we identify the rectangles, we map each rectangle to its constructor and make a card out of it, and now we've got a bunch of cards. That feels good. Let's pull this out. Okay, so we'll call it utility again. New file. This will be UI image. Coming, okay. Swift file. UI image plus crop. Okay. We'll worry some other time if it should be more general, but extension UI image. All right, and we'll paste the crop method in. Give me an image. Well, I don't really need to do image, right? I can just say self. Sorry. I think anywhere I say image, I should say self. I should not pass the image in, just the bounds. Okay. Source image. Okay, wait. Am I not passing the image? Source equals self.cg image. Okay, let me do it, undo again. Okay, image, source equals image.cg image. What the heck is this? Is source image what I passed in content view? Source image, okay. Is probably the same thing up here, right? Source image. Okay, let's you find these things as you go. Okay, all these are going to be selfs, not source image. They should have been image in the first place. Okay, let's do self. So I try and get the new one right before I hook it in. Okay, so if you're a UI image and you're asked to crop to bounds, you will get your CG image, which is the core graphics, the real representation of it, and you will use its cropping to the scaled bounds. Okay. So CG image has crop, but UI image does not, apparently. Or at least we're acting like it. Okay. CG image. Okay. Cropped image. Now let cropped CG image, cropped image, and return that. Well, let's get it working, and then we'll simplify this a little further. Okay, so content view, I'm saying I don't need this anymore, so I'll just say it's gone. Somebody should complain, like right here. Yep. Image, source image. We're going to use source image.crop. And we can take the image out, crop to the bounds rectangle. Let's run. Oh, he found it now. Okay, let's run. Make sure it works. All right, the real thing should be the cards. Okay, they still look good. All right, so we've gotten rid of XX crop. And I like having this out of here. I really do like that because it just clutters up. There's plenty of stuff going on already with the UI. So let's get the clutter out a little bit. Okay, and UI image plus crop. The thing I noticed there's no reason to create this variable. I can just return this. Okay. Yep, that's good. All right, so let's commit that. All right. We should take a break, really about 10 minutes ago. So I think we're at a good point to take the break. We've just about got that doing what we want there. I think we'll do a little cleanup on the content view if we can, and move on to making sure they come out in the order we want. So that should be good. All right, so we'll just take like 3-minute break and pick up from there. Welcome back. All right. Let's see. Well, I had that deck. Now I keep losing images. I don't know if I close that or not. All right, so we've taken the photo, we've extracted cards. I want to put them in order. Oh, I guess I wanted to look at content view first. Let's see. So we got our source image. We have the two tabs, one for the images, one's for the cards. I'd like to just not extract anything and make sure it doesn't blow up when I just start here. Okay, empty cards. I'm not sure the list of cards text is so helpful, but that's where we are. All right. We got our cards, and this image view, it's kind of a helper, I guess. That's image view here. Create some view, which consists of the source image with a bunch of overlaid rectangles. Okay, and then the go button that actually populates those rectangles. So starts out empty, and then it gets populated when it finds them automatically. All right, we map them into cards, so it's got them from that. I could, I could modify it to go through the rectangles, go through the cards and pull the rectangles, but I think I'm correct in treating them as two different things. That the rectangles really are sort of a geometry domain on the image of the card, of the whole set of cards, and they're not individual cards at that point. I don't think. I mean, we can change our mind, but that's where I am now. All right, card list. This is our display of cards. It's actually not bad. We're just showing the images and then this text string. I don't know if we need that. That is coming. It's just, yeah, the card ID. All right, so you can see it in the image. We got a card. It's the word card and then followed by its UUID. It may be helpful for debugging, but I don't think we need it in our real content view anymore. So let's take this out. And now we're just showing the images of the cards. I think that's okay for now. All right. This text, I don't know if I want it. I'm going to take that out. It might be nice. Well, whoops. If you had named this picture or something like that, it'd be nice to have that name up top there. But I'm gonna take it out for now. All right. Now the card outline. This to me, well, let's move this up. It's not really part of the card list. It's more part of the image view. Okay, so let's pull this up to here. Card outlines, okay. And then the card list. Okay, now that's a little bit redundant to the scaling we just did. Okay, I'm going to let that sit for now. All right. This should run, should be no different. I think well, it'll be a slight bit different. I don't say list of cards anymore. I don't have the names of the cards. I just have individual cards all in a row. You can't do anything with them except scroll up and down. Okay. Let's go back. So we just did some UI cleanup. Rearranged functions. Okay. All right, now I did it again. I lost it. Okay. The thing I noticed when I think about putting these in rows, Okay, I have an algorithm kind of in mind, but what I see, just if I take off my human vision and I turn on computer vision, or mechanical vision or something, um, these cards are not perfectly aligned vertically. Okay, this one's a little lower. This one looks like the tallest, and then it looks like I'm sort of sweeping down as I go across. Okay, they're each a little shorter down there, so it's kind of upside down U-shaped at a very low level. Second line, the first card could be the tallest. The first three are pretty close. Maybe the tail of the fourth one. The other two are not. But if I look at this as a human, I see 5 rows, one of which is very short, and all those should be treated as in their corresponding row. Okay, and I have no overlap left to right, so I think I'm okay with that. So my algorithm I'm imagining is I'm going to sort these cards by their, I think by their y-axis. Okay, it's like to find the rows. I'm going to take the tallest card, and anybody within a certain range, anybody whose min x is in a certain range is going to be treated in that row. And I think the range is probably like the top of the card to the middle of the card, something like that. That might be a tweakable thing. But yeah, so I think like the lowest point of the row tops, the lowest min x in this first row is probably this, and it's certainly higher than halfway up on that one. If in order started down here, I'd I'd kind of say like, well, maybe that should be a different row, or at least I'd buy that it's treating it as a different row. Okay, so what I'm going to do is take the min x, sort them all, take the min x. That is a card definitely in the first row. Anybody who's top min x is within 50%, within the top half, or maybe 2/3. The top half of this card is going to be considered in row one. And then I'm going to sort them by, oh, I keep saying X instead of Y. Huh. I'm going to take them in Y, which should give me this, and sort them by X. Okay, sort the ones that are in that range by X. And then I'm going to have a set of cards that are left. All right. Of those ones that are left, I'm going to do the same operation again and get the next row and so on. That's my idea anyway. Okay, so what I want to work with then is really the coordinates of these things. Okay, and I don't know if we know them. Okay, we kind of don't. Let's see the code. Okay, yeah, would I have to double click it and keep it? Hey, I'm remembering these things slowly. Okay, where's the card? Right, the card does not know his coordinates. So the image knows it's, I think the image is going to be like 0, 0 width and height kind of thing, because it's the cropped image. Maybe, do I need to know the rectangle too? The original rectangle or the scaled rectangle? The original is almost enough. Yeah, it always comes back to these coordinate systems. Like, how many do I need? I've got at least 2 going, and probably more. Actually, I have at least 3 going, because um, the identified images, they put the corner 0, 0 at the lower left corner, and the image stuff puts it at the top left corner. And it's also flipped like vertically, so it's I end up kind of with three coordinate systems here. Um, what is going to be more valuable? Am I better off with the 0 to 1 scaled stuff, or the true coordinates on the main image? I'm going to go with the rectangles. Okay, so let's figure out what we want to do here. Um, I'm going to say this is a card function. It's not really card, is it? It's really a function of this array. Okay, which, I mean, a list of cards is probably a deck, right? I mean, that's a pretty normal name for this thing. And I also know that if we make this a standalone object, I just remember it's messy. There's a way to make Swift UI work, but it's just like more work than I like. I'm so lazy, but yeah, I don't want to mess with it. All right, but I think I will try and not make the mistake of putting this row recognition stuff um, on the card itself. A card is just a standalone image. It's somebody's got some data. Maybe it doesn't even go on the card at all. I don't know. Where were you in the original coordinate system, or in the original 0, 1 coordinate system scaled to be from the top left? Um, is that a card? I want the card to be this semantic thing. Okay. Hmm. Well, let's see. What's going to happen? I'm going to hit the go button. It's going to find the rectangles, create the cards, and then it should sort the cards by either horizontally or vertically. What else would I want? Oh, another one I thought about was hierarchically. Did I write that down somewhere? Okay. Um, take a card, flipping right on the back, sort. Okay. Yeah. Let's see what we're talking about. So I think we've successfully extracted the card to the image. That's kind of a big deal. Um, and I'm happy that part seems to work. Okay. But now I want to sort the cards. I guess horizontally. Other options vertically or hierarchically, I would say. Let's see if I think we have examples of both. So this one is horizontal. I think Yacht 2 is vertical. Yeah, so Yacht 1 that we've been looking at has rows. This one has columns. Okay. Hierarchical, I would say it's like indented. Okay. Um, like maybe 25% is the cutoff or so. If you indent 25%, then you're starting a new level. And then the cards beneath you at the same indentation or to the right are at that level as well. Sort of a 2D hierarchy, I guess. That's advanced. We're not there. But right, what we are, sort the cards horizontally. Okay. Oh, what do I want? I guess I'm coming down to this question of where this metadata that's the original rectangle going to live. Is it part of the card or is it part of something else? Okay. And then I'm going to write a deck test. And I don't have a deck, and I know I need it, but we'll get there. Okay, this is a test. Okay. Oh boy. What I would like. No, I really want to just give you some cards and say sort yourselves according to some criteria. And that to me says the rectangles have to be on the cards. I don't care in a way what rectangles coordinate systems I have, so maybe this 0 to 1 one is simple enough and easy enough to use. Let's assume it. Okay. Something about sorting horizontally. Can I call it an X sort? Would that work? Row sort? Yeah, row, row sort, I guess. Puts, How about a row sort with 2 cards in same row? Okay, and honestly, I don't care about the image. Okay, sorry. Let's make a card. What's he look like? He's got an image. I'll just say image equals. Can I do that? Okay. Let's make the card with the image, and I'll call it card 1. Card 2 with an image. Okay. Now I got to put coordinate systems somewhere. Okay. Somehow I get coordinates. I say row sort of an array of cards. And let's let deck equal that. Okay. And in this case, I just want a linear sort, a linear list of the cards in row order, rows, then columns. I know there's probably a better mathematical word for that. All right, but I'm going to assert equal deck, and then that should equal. Let's set things up so it's card 2, card 1. Okay. Now we know we need a rectangle. All right, so let's say rectangle XY width height. And this one's got another rectangle. XY width height. Okay. All right, so I would like to make it so that card 1 is higher. Okay, so let's put him at 10%. And let's put him in the middle. And the width height thing, we don't care too much. Width 0.2, height 0.1, whatever. Okay, so this card is horizontally in the middle, down a little bit. Okay, his height is 0.1. Let's make his height 0.2 and his width 0.3. Okay, so this card I want its x-coordinate to be less, so let's take 0.2. I want its y-coordinate to be a little bigger. So the the height is 0.2. So from 0.1 to 0.3 is the width, no, 0.1 to 0.3 is the height of that card. And if anybody's in 0.1 to 0.2, they should be in the same row. So let's say 0.15. Okay, and that doesn't matter. And the width, I'm just going to make the same-ish. Doesn't really matter. The height, they vary in real life, so it's not a big deal if they're not exactly the same. Okay. So the top of this second rectangle, okay, well, let me say this again. Card 1 is in the middle of the page. Card 2 is to the left of it because it's at 0.2. Card 1 is slightly higher than card 2. And so I would like card 1 to be the thing that determines the starting point of the row. And then it's in the range 0.1 to 0.3. So the half of that is 0.1 to 0.2, and it's under that. So it's overlapping vertically in a pretty tight window, and the height and width and height into the cards don't really matter too much. Okay, if I try and run this, row sort doesn't exist. All right, sorry, if I try and run this test. Okay, oh, what's your problem? Extra argument. Oh, right, our cards don't take rectangles. We don't have a row sort, and since it has no idea what you're talking about, it can't do an assert. All right. Oh, I would like to say then that cards take rectangles, not just the image, but their placement is a CG rect. Okay, and we're going to assume it stores it placement of type CG rect and self placement equals placement. Okay. Where did my test go? Okay, so that'll hold that. And now row sort. Well, let's just define it right here for now. Okay, I'm going to take a step. Deck.rowSort, we'll give it a static method. Okay, and to give it a class, let's see, that's a model. A deck, okay. Public. I don't remember how we do these. Is it static? Func row sort takes in a array of cards. Okay. Missing return. We'll just return empty cards. Okay. We want something that's going to fail. All right. Cannot find deck. Okay, I guess that's the way it does it. All right. This thing should fail pretty drastically. What? Oh, everybody else. Let's default this. for now. Cannot find deck in scope. Okay, import deck. Okay. Oh, it's not deck. I've already got testable import. What's wrong? This should be part of deck. Let's see, card. Yeah, that seems okay. That'll probably help. Okay, test field should be empty instead of the 2 cards. Okay. Right. Um, all right, what I would like to do, okay, row sort. So I want to go through the cards and get their rectangles and find the min x of any of them. Okay, so let's take in dot map. Let me do this. Syntax is killing me. Is it func x arrow? We've done something like that. It's something in, right? Okay, we know this. Deck in.map, we want to say card in. All right, and then for each card, let's just take placement dot min x. Okay, now how do I get that placement? I think I can just make it. Oh, how do you do that? It's like a. I think. Do I just do this? Do I make a var out of it? Is a CG rect, and then if we just take placement, return placement. Is that my accessor? Okay, card location. All right. I probably, let's make it input. I think I hit a reserved word or semi-reserved word. Input map in. Yes, okay. That is min x is that. Okay, now want to sort the cards. Well, let's not worry about the vertical overlap, but let's just worry about, or no, maybe we do. And I'm worried my steps are going to be too big. So let's not worry about the vertical overlap. Let's just return the cards sorted by their x coordinates. To do that, I don't even need this. Okay, so let's take input sorted by card. Let's see. I think this is your first card one dot placement dot min y. Oh, min x. I'm already screwing up stuff, aren't I? This one I want to be min y here, but that doesn't matter for now. All right, so card one placement dot min x is less than or equal to card two dot placement dot min y. Excuse me. And I'll just return result. Okay, so at this point, I'm sorting them by min x. So whoever's got the furthest left x coordinate is the first card. So they should come out in the order I said, because card two is less than card one. Okay, let's see if this function does the job. I expect yes, by the way. Oh, okay, what did we get? Card 6-3 is not equal to card 05, card 6-3. Okay, OF. It came out card 1, card 2. Why? Let's go read this. Sort the collection in place. Interesting. Using the given predicate. When you sort elements that don't conform to comparable, past the closure, this method returns true when the first should be ordered before the second. The closure follows an ordering. Pass the greater than operator as the predicate. Well, okay, press, oh, you want descending past greater. Okay, so I want less than or less than or equal. I guess less than is probably okay. Must be a consistent weak ordering. Okay, that's fine. Come back to n log n. Okay. Why did we not get that? Less than, I'll use less than, strict less than. Card placement min x, less than card 2 placement. How about min x? Ugh. Okay. Let's try that again. I mix up x and y, row height, row column width height, like all the time. I expect to pass like I did last time. All right, so that's fine. Hmm. Well, I think we're due for another break. Let's take a break, two or 3 minutes. We come back. We're going to make the sort harder. I don't know if we need to rewrite things, but maybe we'll just sort one row or something like that. Okay, but we'll take that break. I'll get a drink. All right, see you in a couple minutes. All right, welcome back. Okay, so, hmm. Well, I know I want some cards to sort as not being in the row. I don't know what to do. Um, maybe row sort can only sort the cards that are in the same row. It's giving me a subset. So um, let's change the name. That'll make it better. Oh, I can't do that here. Okay, factor. Can't do that here. Wow. Okay. Can I do it over here? Rename. I'm gonna sort. I'm gonna sort the top. What is this? This is, let's say it's a top row sort. Okay. Now you give me input. My understanding is, and we'll test this, I guess, the rules are when you pass an array, you're actually making a copy of it. And in this case, I'm sorted by affects that copy, but it doesn't affect my original. All right. So my goal here is I'm going to make a slightly harder test. I'm going to add card 3 in. Okay, so card 3, we don't care about the image, but the CG rect. Okay, I'm going to put it to the right, x 0.75, y. Now y, I'm going to say it is too far down. All right, so for us, anything from 0.1 to 0.2, because that's halfway between 0.1 and 0.3, should be in the first row. But if you're at 0.25, you're offset slightly. You're offset more than half a card. Okay. Y 0.25, width doesn't matter, height doesn't matter. Okay. If I ask you to sort card 1, 2, 3, I only want to get back card 2 and card 1 in that order. Okay, so because the y coordinate is more than halfway down from the lowest card, it doesn't qualify as being in the top row. All right, this should fail. It'll probably return all 3 cards with number 3 last. Okay. We expected C28 F1. We got C28. That's the expected. Okay, so we got all 3. We expected 2. All right. I think I'm moving forward here. Okay, now I need this min y stuff. Okay, so I I want to find the card in my whole deck that is the highest, nearest the top. Okay. Um, that gives me a coordinate. Do I want the card with, Well, here's another way to do this. Let me see. Maybe this is, I'm going to worry about optimization later. So um, let's say input dot sorted by. Okay, I'm going to take the list of cards and sort them by their y coordinate. Okay, so it's sort of the same as the other, but with y. Card 1, card 2, in card 1 dot placement dot min y is less than card 2 dot placement dot min y. Okay, so at this point I have my input is sorted by y, and let's I think I can let's see sorted this is highest to lowest is that. Okay, and then, well, let's say first row candidates. Okay, I'm going to sort by that, but then I want to keep only the ones. Okay, let's, oh, right. This is high, how about top to bottom? Okay, sorting by the y-axis, I've got the cards sorted from top to bottom. Let. Okay, if I take top to bottom dot first, okay, we have any cards, we know it exists. We'll take that for now. Okay, if I take that, that's a card. Okay, so top card equals that. Let. Okay, so we take our top card, and then we're going to take the top to bottom dot filter. Okay, is included card to boolean. Okay, and how you get that there is card in, and you're included if your min-x is less than the first card's. Let's say, I'm just going to get all the points out there. The high is really top card dot min x, min y, sorry. And the limit is top card dot min y plus top card dot height divided by 2. Okay. Top card dot placement. Okay. And that, okay, so that gives us a limit. I don't know. This is kind of a big step, isn't it? Okay, so this is included. Well, you are included if your card dot min y is less than the limit. Okay, I think we're okay. High is probably not needed. All right, so we find the first card, the top height-wise card. We go halfway down its height, and anybody who's lower than that, whose min y is lower than that, should be in our list. Card dot placement. Min y. Okay. Anybody whose min y is below the limit is in the first row. Okay. Let's return. How do we best write this? I guess maybe that's return top to bottom, filter to the left that, and then sorted by the x coordinates. And that is already returned. Okay, do I believe myself here? The cards sorted top to bottom are sorted by their min y coordinate. Then we take the top card and find its, I guess we're trying to find, well, we're trying to find top card dot placement dot, there's a word for this, mid y. Actually, is that even more concrete? It's not mid x plus this, it's just mid y, I think. Let's see what that is. I think that's halfway between min x and min max x. Right? So I think, or min y. Yeah, you know which letter I'm after. Okay, that. Okay, let me inline this. Okay, see if things make sense. All right, we'll take the top to bottom, sort the cards by their y-axis. We'll take the topmost card and its mid y, meaning halfway between its min x, sorry, its min y and its height. Anybody whose min y is less than that is in the first row, and then we'll sort all those cards by min x and get them in there. Okay. At some point, this dot placement stuff may have to go away. It's annoying as it is. Now I think this should pass. So card 3 should be excluded. All right. Oh, golly. Okay. Let's commit. We are calculate. How about order? Sort cards in the first row. Find and sort cards in the first row. Now, I don't know if this first row function really is what anybody wants, but it's by the way I'm computing it, it's what I want. Okay, now let's handle a border case. Okay, Um, to test row sort with no cards returns empty array. I'll even say empty deck. All right. Control tab. No. Nope. Control Y. Okay. Let's see. So this one will still need an image, and maybe I can just pop that up to here. Okay. We'll take a card. We only need a card. We don't need an image or a card. Let's make a deck and we'll insert on it. Empty list. We should get an empty list back. Okay. It's forgotten that this is a test. I expect this to fail. Unexpectedly found nil while unwrapping optional. Yes, so I just need a guard clause up here because we said there will always be a first, knowing that this day would come. All right, if input.count is empty, then we're just going to return, well, let's just return input. That's kind of fair enough. Okay, keeps the types easier. All right, and these tests again. I guess we'll stop and then run them again. Now I expect to pass. Okay, so if you have an empty deck, we just kick you back already. Otherwise, we pull out the cards in the first row and give them to you sorted. All right. Now, this is really top row sort. Top row sort and top row sort. Okay, and the new function, so what I want to do is I want to fetch all the cards in order. So I want something that accumulates the results of these first row sorts and then removes the ones that don't fit. I'm not saying that well. Let's see if I can express it with a test. I guess I want to say row sort includes all rows. Okay. So I'm imagining we're going to have some cards. Let's just take this example again. I think it's probably good. Okay, and I will pull this up. Again, we're not looking at the image, so we don't care about it. Should be good enough. Okay. Yeah, so I've got these three cards. What I expect from my full sort, okay, so we'll let deck equal row sort of card 1, card 2, card 3. Okay, and actually let's put the x coordinate on this one really low. Let's make him 0.1. So I'm doing a card that's on the left, sorry, in the first row looks like a card in the middle and a card to the left of it. And then the second row looks like a card way to the left. Okay. But the first card is the one that determines the top. All right, now this card, 0.25 is just outside the range. I could even make it, I'll make it a little tighter, 0.2120001. How's that? Okay, so I'm uh, I'm saying this card just missed being in the right range. Okay, so if you sort those with that, then what I expect to get back from deck, I expect it to be card, let's see, the first row is card 2, then card 1, and then card 3. Okay, so card 2 and card 1 are in the first row. I'm going to call this row order. What do you call that? It's like major and minor. I know I'm going to get that mixed up. Okay, row sort for now. All right, card 2 is the furthest left. It's in the first row. Card 1 is in the middle. It's in the first row. Card 3 is the furthest left, but it's in the second row. Okay, that looks legit to me. All right, so let's make another function, row sort, and you give it some input, which is an array of cards, and you got some output, which is an array of cards. All right, what's the return? Well, for now, let's just return top row sort. We know it's wrong, so our test will fail, and TTD will be happy. Okay, so row sort should exist now. We expect we're just going to get card 2, card 1, because they're the only two in the row. And I think it's going to be a pretty complicated deal. Okay, all the others should still pass. Build failed. Why? Cannot find, oh, it's deck.row sort. Okay. All right, he failed probably because there's only 2 cards, right? 1, 2 is not equal to 3. Okay. Now, again, I don't know if I'm making things too hard. My idea is I want to take the top row sort. Okay. Let's make a result. Okay. Var result equals input. No, it equals nothing. Okay, so far we have not accumulated anything. Okay. Your type is cards. Array. Okay. Result is an array of cards. It's what we're going to return in the end. Okay. What I want to get, well, basically, I want to take row by row and accumulate them in and remove them from my input and keep going until I have no more input. Okay, so, well, not empty. Okay, what am I going to do? Well, I'm not going to return that row. I'm going to append it. I'm going to pull out the top row and append it to my result. I think append will take the right type. Well, let's just accumulate them for a moment. Okay, next row. Let next row is equal to that. Okay. What's your problem? Okay. Now I want to append New element sequence. Okay, so let's append next row. Okay, so I have the first row. I append it, and then I want to remove that stuff from input. Input dot, I don't know if I can remove. Remove all where? Some condition. Well, my condition is card in next row. Okay, so no exact match for remove all. You just told me it was there. Let input equal that. Let's go see it. Wasn't it input dot remove? Oh, is it just remove where? Remove all where? Okay, what's element is not a member of self? Yeah, no kidding. Oh, this is not enough. Okay, sorry. Where card is in, I guess I'm going to make a set. Where next row contains card. How am I feeling about that? No exact matches to call remove all. Cannot use a mutating member. Oh, so it's going to mutate this. Okay, is that better? Cannot use a mutating member on a mutable value. Input is a let constant. I don't know what that means. Mutating member on a mutable value. Input is a let constant. Well, maybe I'm going to make a var. Okay. Still around equals input. Okay, can I do that? Where still around, and this is still around, and this is still around. Okay. If you've still got cards around, then pull out the next row, append the result of that to the result set, or result sequence. If still around has anything in it, remove the ones that contain cards from the next row. Let's call this first row. Okay. We get the first row from the cards that are still around. We append the contents, and then we remove all those cards from still around. If there's anything left and still around, that. Okay. I think this is what I intend. Whether it works, that's to be determined. But I believe it should work. If it works, we're good. Okay. So I think I've got my row sort. All right. That's a good place to stop. So it's where we'll stop. Next time we'll pick up. Let's see. I'll check this in after we roll camera, whatever. But anyway, we'll pick up there next time, and let's when we create the list of cards, we're going to pull out those images and then sort them according to the row order using this method. And I think with that, we'll get the sorting and the cards will be in the order we want, and we'll go from there. All right, well, thanks for joining me. Let's see, this week I expect to be Friday, same time, and again next Sunday. Um, my schedule's fluxing around the next few weeks, so we'll see, but that's the plan. So hope I can catch you again sometime. Thanks for joining me today, and I guess I'll try and patch up at least a little intro on the missing video there for the YouTube version. All right, take care. Bye bye.